Now we can talk about the higher order derivatives. Now remember this, we have, for example, if we have a function like x squared, so its derivative will be equal to, by using the power rule, we have 2 times x. Now, if we take another derivative, if we want to take the derivative of the derivative, so we call it second derivative. It means we are taking the derivative of the derivative. So which means you are taking the derivative of 2x, which is, 2 times the derivative of x, which is 2 times 1, this is 2. Now, if you say we are taking the third derivative, so it means we'll take the derivative of the second derivative. So it will be, what's the second derivative of x? So it will be 2. The derivative of 2 will be equal to 0. So we have this notation here. The first derivative, the second derivative, the third derivative, the fourth derivative, the fifth, it goes like this. And its notations in different notation, it's in Leibniz notation, it will be f over dx, it's d squared f divided by dx squared. And we call them like the first derivative, second derivative, third derivative, fourth derivative, and fifth derivative of a function. The key idea here is if you see, okay, this means 3 means here, we're taking the derivative of this, and again, and again. So 3 times derivative, or derivative means this. Okay, let's look at this question here. Find the first 3 derivatives of x cubed plus 5x plus 7. Then it says find the nth derivatives after n bigger than or equal to 4. So let's start with the first derivative of f. So f prime x should be x cubed plus 5x plus 7. Then the derivative of x cubed plus 5 times the derivative of 5x, and then the derivative of 7. And this one will be by using this power rule. It will be, okay, you can use this one here. X cubed prime will be to 3 times x, 3 minus 1, which is 3x squared. So it will be 3x squared. And the rule here, 5 times x, 5 is not, this is a coefficient, so it's not affected from derivative. So the derivative of x is, so you can take this one as the first power, so it will be like 1 times x to 1 minus 1, which is 1 times x to 0, which is 1. So the derivative of x is always 1, you keep it in your mind. So this is, it will be 1, and then the derivative of constant, as we know, the derivative of constant is always 0, so we have 0 here. So this will be 3x squared plus 5 times 1, so which makes 3x squared plus 5. Now, if you want to take the second derivative here, so it will be the derivative of the derivative, which is, okay, this one was from the previous part, it is 3x squared plus 5. So take the derivative again. So 3x squared, you can distribute derivative, it will be 3 times, distribute the derivative, this will be 0, and this will be 3 times 2x, which is equal to 6x. Now you can, here I'm applying this rule again. Okay, you can check it like x squared plus x squared, you will see, you'll get this one. Now this is 6x, and now we take the derivative of, okay, third derivative means like you're taking the derivative of the second one, second derivative. So it means we are taking the 6x, take its derivative, will be 6 times the derivative of x. We know this is 1, 6 times 1. Now, when it comes to, okay, I will erase the previous ones. And then when it comes to the fourth one, fourth derivative of x will be of f will be equal to the derivative, the derivative of the third derivative. So the third derivative is 6, the derivative 6 is 0. So then if you take the fifth one, then it will be the fourth derivative, the derivative of the fourth derivative, which is the 0 derivative, which is 0 because it's constant. So after this, after n bigger than 4 or equal to 4, then we will end up with this. Keep taking the derivatives, we will have all real prime, so which is equal to 0 for n bigger than or equal to 4. Now let's let's do the same thing here. This is the same idea. Let f x is this. Compute as many derivatives as possible. So let's start with this f prime of x, which is equal to, okay, you don't have to do it this way. I'm showing all the steps because this is new for you, so I want to show you the steps. But if you are good at it, so you can skip some of the steps. But since it's new, I want to follow all the rules. So I distribute the derivative to all terms because this is sum. We can distribute the derivative to sum or difference. And then I use, again, the derivative rule for the power. And if I use this one for x to the fifth, so it will be 5 times x to the fourth, and plus 4 times x to the fourth prime. 4 is not affected. This is coefficient. This is a constant term coefficient here. Then if you use the x to the fourth here in the power, in the power rule, if you use this x to the fourth, that will be 4 times x, 4 minus 1 is 3. And I can erase this one and I say it's x third power. And this is the constant here is like a prime is equal to 0, so this will be 0. So when you take the derivative of this again, so this will be 5x to the fourth prime plus 4x cubed prime. Okay, I'm taking the second derivative. 5 times x to the fourth derivative plus 4 times the x cubed derivative. So be careful here. Is 5 and 4, they're multiplied, they're constant here, the coefficient, so they're not affected by the derivative. So 5 times 4x cubed. So if you use the rule here, we did earlier, so it will be 4 times x cubed. And then this, if you take the derivative again, it will be 4 times. Okay, the derivative of this will be 3 times x squared. So this turns out to be 20x cubed plus 12x squared. So when it comes to the third derivative, you're taking the derivative of the second one. So which means 20x cubed plus 12x squared. Take the derivative of this will be 20, the derivative of x cubed plus 12 times the derivative of x squared. And then it will be 20 times 3x squared. And this is like 12 times 2x. This will be 60x squared plus 24x. Okay, I can keep doing this. And the fourth derivative will be the derivative of the third derivative, which will be 60x squared plus 24x. This derivative, which will be 60 times the derivative of x squared plus 24 times the derivative of x. So 60 times 2x and this is plus 24. And then the fifth derivative will be the derivative of the fourth one. This will be 120x plus 24, its derivative, so it will be 120 times the derivative of x, which is 1. This will be 0, and then 6 derivative will be the derivative of the fifth derivative, so which will be 120, then 0. So when we get to 0, the others, the 7 and the others, the 8 and the others, all will be equal to 0 because we reached the constant. Now let's look at the meaning of the derivative on the graph of a function. So assume this is the graph of the function f of x. Now when we say the tangent line to f of x at x equal to a, we mean this tangent line. So tangent line to y equal to f of x at x equal to a means the line touching the graph at the point AFA. So this means this line here, this line touches y equal to f of x at x, no, at a f of a. So it has tangent, we call this situation tangent to this graph. This line is tangent to the function at this point, like a f of a point, this f of a, this corresponding y value here. Okay. Now here we have the derivative has a meaning at this point. The slope of the tangent line here at a f of a can be calculated by the derivative of f at this point. So this is our point. The touching point here is like a f of a, and the green line is the tangent line here. Okay, now f prime a is the slope of the tangent line to y equal to f of x at the point x equal to a. So then the slope here, okay, I'll make it green. If I can, okay. So it will be not green, but anyway, something like this. So its slope here is equal to f prime of a. So the first one is saying this, and the second one is saying the equation of the tangent line. So the equation of the tangent line, okay, the slope is given. What is the slope? This is f prime of a, and the point is given, so it will be a f of a because the line is passing through this point here, and by using these two we can write the line equation. If you remember, it will be y minus y0 times m times x minus x0. So here our m is this, our x0, y0 is this. So if you remember this line equation, so we are applying this line equation with slope f prime of a, the slope, and the point is a f of a. So the rest of the exercises are about this. Let's try to do this one here. Find an equation of the tangent line to the graph of f of x equals to 1 over square root, 1 over x at x equal to 1. So let's remember this fact here. The slope of the slope form of the equation of tangent line is given by y equal to f of a, f prime of a, x minus a. So what we need here is, okay, if we want to write the tangent line to the graph of f of x equal to 1 over x at x1, we need to write, okay, what is a? A is definitely 1 here. And then we need to find f of 1, and we need to find f prime of 1. So to get f prime of 1, we need to get f prime of x. So if this is 1 over x, so how can we get f prime of x? So I want to remind you this one. This is, you can write it as a power of x, which is x to the negative first power. And then you can use the rule here. What's the rule? The power rule for the derivative will be n times x2 n minus 1. So if you write here x2 minus 1, so it will be minus 1 times x2 minus 1 minus 1. It will be minus 1 times x2 minus 2, which is 1 or minus 1 over x squared, right? If you do this. So it will be minus 1 over x squared. So when you put 1 here, you'll get minus 1 over 1 squared, so which will be minus 1. So I got this one now, and I need f of 1 here, right? F of 1 is here 1 over 1, it's 1. So I got these two things. So I got the slope. So what is the slope? This is the slope. And we know the point here. So, or you can directly write the equation here, like y minus f1 equal to f prime 1 times x minus 1. F prime 1 is minus 1. F1 is 1. So you can say y minus 1 equal to f prime 1 is minus 1 times x minus 1. So then you will get equal to 1 minus x plus 1 plus 1. We will get y equal to negative x plus 2. So this will be the equation of the tangent line. Now we have the same thing. Again, find an equation of the tangent line to f of x equal to square root of x at x equal to 4. So let's remember the fact here. The point slope form of the equation of tangent line is given by y equal to f of a equal to f prime of a times x minus a. Tangent line to y equal to f of x at x equal to a. We have to say that. Okay. Now let's we have to do, like, our a is here for sure 4. So we need to find f of a, which is f of 4. And we can find it. This will be 2. And what about f prime 4? How can we find it? So f of x is square root of x. And we can write this one as x over 1 or x to 1 half. Okay, we are trying to write everything in terms of power of x because this is the only rule so far we learned. So I'm trying to do everything with this. Are there other rules? Of course, there are lots of them, but you're seeing only this one now. X to the end, derivative of x to the end is like n times x to n minus 1, which is like 1. Okay, let's use it here. Do we get it will be 1 over 2, and this is 1 over 2 minus 1. It will be 1 over 2 x2 minus 1 over 2. If you do this one, this will be like 1 over 2, 1 over square root of x, you can write. So this has to be then 1 over 2 square root of x. Now it says what f prime 4 is equal to 1 over 2 times square root of 4, which is f prime 4 is equal to 1 over 2 times 2, which is 1 over 4. Now, we are done with f of 4 and f prime of 4, so we can directly use the formula here. Y minus f of 4, which is 2, is equal to, here it's coming from here 2, and then f prime, which is 1 over 4, times x minus 4. So if you do this calculation, it will be y minus 4 is equal to x over 4 minus 1. You do this calculation. So you will get ay is equal to x over 4 minus 1 plus 2, which is x over 4 plus 1. So this will be the equation of the tangent line to f of x equal to square root of x at x equal to 4. Okay, that's it.